Question 1. What are two potential pitfalls of using recursion? The two main pitfalls of using recursion are stack overflow and inefficient performance. 1. Stack overflow. Recursion relies on function calls being placed on the call stack. If the recursion depth becomes too large, such as with deeply nested or infinite recursive calls, it can cause a stack overflow, crashing the program. Example, factorial. In a recursive factorial function, we use public int factorial in parentheses intn. Then we have to open the bracket. If in parentheses n less equal to 1, then close the parentheses, we make return 1. Then return n times factorial in parentheses n minus 1, close the parentheses, then we close the bracket, close the function. 2. Inefficient performance. In cases like the naive Fibonacci sequence, recursion may lead to excessive recomputation of the same values, leading to exponential time complexity, which makes it highly inefficient for large input. For example, Fibonacci. In the recursive Fibonacci function, we use public int fib in parentheses int n. Then we have to close the parentheses to open a new bracket. If n less equal to 2, return 1. Then return fib in parentheses n minus 1 plus fib in parentheses n minus 2. Then we close the bracket. So, how could you overcome these challenges? For stack overflow, use iteration instead of recursion when possible. Iterative solutions avoid the use of the call stack and handle larger inputs more efficiently. In some languages, you can apply tail recursion, which allows the compiler to optimize recursive call and prevent stack overflow. For example, factorial using iteration. The example code public int factorial alternative in parentheses intn. Then we have to open bracket. Int results equal 1. For int I equal n I greater than 1. Then I close the parentheses. Then we have to make another bracket result times equal I, then close the bracket. Then we have to make return result. For inefficient performance, use memoization, like call by name, to store the result of expensive recursive calls. This prevents the function from recalculating the same value multiple times, turning an O in parentheses 2n, close the parentheses, problem into ON. Alternatively, switch to an iterative solution or dynamic programming approach, which is often more efficient for some problems like Fibonacci or factorial. So example code for Fibonacci with memoization. So public long Fibonacci in INTN dictionary, the lesser symbol, INT long greater than memo equal null. So if memo equal null, memo equal new dictionary less than int, long greater than, then close open and close parentheses. Then we have to make if n lesser equal to 2, return 1. If memo dot contains k in parentheses n, close the parentheses, then return memo inside the bracket n. Long result equal Fibonacci n minus 1 memo plus Fibonacci n minus 2 memo. Memo n equal result, then we have to make return result. So this was the example of Fibonacci with memoization. Thank you.